Hey, welcome to example number 3. We have a paintball question. So imagine a contestant is firing a paintball horizontally from his gun, and it's 1.5 meters above the ground, and it misses its target and hits the ground. We want to know how many seconds does it take for the ball to go from here to here? So how long is it in the air? And then what is the maximum horizontal displacement, or what we call the range of the ball, from here to here. So we're looking for this distance x. Now, so the first step you would do in this kind of problem is you would draw a picture of maybe the paintball gun and the velocity leaving out here, and then define an appropriate coordinate system. Now, normally it's easiest to place the origin at the position of the paintball. But you could also choose to put your origin down here at the base of the ground and just call the initial vertical position of the ball at 1.5 meters. It's really up to you. If you put your origin here, then the final vertical position is going to be negative 1.5 meters. Okay, so now we're going to list all of the knowns and unknowns, and I like to classify them into two different categories: the horizontally information and the vertically information. Now, I know that the horizontal acceleration is always 0 because we're assuming no air resistance, and the vertical acceleration is negative g, or negative 9.8 meters per second squared. Okay, so that's the acceleration. Then we'll go on to the velocity. Do we know the initial velocity in the horizontal direction? It just so happens that this is fired horizontally. So we really know the speed horizontally, 75 meters per second. What do you think the vertical initial velocity is going to be? 0. Hopefully you realize that. It's being fired completely horizontal, so therefore there's no vertical velocity initially. All right, moving on to that, then we move into the position. Do we know the initial position? Yes, we've decided to call the initial position along the x-axis to be 0 meters. And the vertical initial position is actually, we've decided to put 1.5 meters by setting our coordinate system 0, 0 here so that the gun is starting 1.5 meters above the ground. Okay, anything else do we know? We got the acceleration, the velocities. Um, Well, the ball starts here and then it ends up over here. We obviously don't know the horizontal position, but we do know that it comes back down to ground level. That means we do know the final vertical position is 0. That's key to realize that. If you didn't realize that, then you'd have a hard time solving the problem. Okay, in A part, we're trying to find the time, so t. And then in B part, we're asked to find the maximum horizontal displacement. So we're trying to find basically x. Okay, now one important key feature that people often mistaken with projectile motion is that the time that it moves horizontally is the same as the time that it moves vertically if you're going from this position to this position. So whether it moves horizontally and you're describing the horizontal motion, or whether it moves vertically and you're describing the vertical motion, the time elapsed is the same. So you can put t here or here, it's the same thing. Okay, so now moving into our problem, part A. We're trying to find the time in the air. You have to kind of look through your equations. You look, if you could look at x equals x sub 0 plus v0 x t, and I have the acceleration horizontally is 0, so this term is going to be 0. So if you look at this equation right here, can we find the time? Well, we do know this velocity. We know the initial position. We don't know the final position. So we don't know this nor the time, so we can't quite start with that equation. We look at the velocity along the x-axis. That's not changing. So the final velocity is the same as initial. That's not going to get us anything about time. Well, maybe we should move on to the vertical motion. Can we solve it vertically? Do we have enough information? Do we have the initial vertical position and the final position? Initial vertical velocity and the acceleration? I think we do. Let's write that equation down. Y equals y0 plus v sub 0 yt, and then minus 1/2 gt squared. Okay, you should, If you want to, you may want to start with just writing, y equals y0 plus v0 yt, and then plus 1/2 ayt squared, and then replace the ay with negative g. All right, let's substitute in here. Now we have 0 final position. The initial position is 1.5 meters plus, this goes to 0 because there's no initial vertical velocity. So that's plus 0. Then minus 1/2 gt squared. Minus 1/2 times 9.8 meters per second squared times t squared. And solving for t, we'll get an answer of 0.553 seconds. Okay, now moving on to part B, we're looking for the horizontal displacement. So we're using this equation now. X equals x sub 0 plus the initial horizontal velocity times time. And we've assumed that the initial horizontal position is 0 to make our life easier. And then we have the initial horizontal velocity is 75 meters for every second. And now we know that it's going through the air vertically and horizontally at the same time, 0.553 seconds approximately. And that gets us an answer of 41.5 meters. So I hope that you realize one of the key things is that although the horizontal and vertical motions are independent from one another, they are connected through time. So the time that it moves vertically is the same as the time that it moves horizontally. And that's it for this example.